2016 FRQ4. The first part of this is asking us to sketch a slope field for the differential equation provided, dy dx equals y squared over x minus 1. So notice that they don't have any dots at x equals 1 because that would cause a slope of y squared over 1 minus 1, which is 0, which is undefined. So wherever x equals 1, they don't even provide dots for you to draw a slope, and that is y. But let's look at what happens when x is 2. So when x equals 2, the denominator is going to be 2 minus 1, which equals 1. So that means that the slope is going to be equal to whatever the numerator is. And the numerator is determined by y squared. So when y equals 0, so let's just kind of group all of this in here. So when y equals 0, then the slope is going to be 0 over 1, which is just a slope of 0. So we should just draw a horizontal line here to represent a slope of 0. Okay, now what about when y is 1? Okay, well that's going to be 1 squared over 1, which is just equal to 1. So our slope is going to be equal to 1. So we need to kind of angle our slant, angle it down so that it points downwards to a rise of 1 and a run of 1. So we're just going to draw like that. Okay, and then when y equals 2, okay, that's going to be 2 squared over 1, which is 4 over 1, so significantly steeper. So what we really have to think about here when we draw this is we kind of have to go from here at y equals 2, we have to go down 1, 2, 3, 4 units and then over 1, because now this represents a slope of 4, run by 1, rise by 1, 2, 3, 4. So then when we draw our slit, we should really try to angle down so that we're pointing at that. So then we're just going to do our best to do that. And this is going to be tough for me on this iPad here. Okay, and you just have to, it doesn't have to be perfect, you just have to show them that you know it's much, much steeper than it is at y equals 1. Okay. Now we already know that at x equals 1, we have an undefined slope. What about at x equals 0? So at x equals 0, that means we're going to have a denominator of 0 minus 1, which equals, I don't know what just happened there, which equals negative 1. Okay, so then that means negative 1 is going to be the denominator, and then y is going to determine the numerator. So it's going to be it's just going to end up being the negative of whatever the y value is. So if we plug in y equals 0, again, obviously that's going to be a slope of 0 over negative 1, which is 0. So we have our slope of 0 right here. Okay, and then when y equals 1 and 2, we already did y equals 1 and 2 was positive 1 and positive 4. So that means that this is going to be a negative 1 and negative 4, because the only difference now is that the denominator is negative. So we're going to draw a slope of negative 1 and then a slope of negative 4, which means we just have to aim for a rise of 4 and a run of 1 in the negative direction. So we're going to aim at this point down here when we draw this slit from 2. Okay. Or I guess we should be aiming at actually this point right here, because it's a 1, 2, 3, 4, and then a run of 1. Okay, so, and we should just make sure it looks roughly the same as that steep slope over there. And then it's going to be, I'm going to erase this so it doesn't go into the 3. It's going to be tougher to draw 3. Oh, 3 is not included. It's just those 6 points. So we're good. This is all we have to do. Okay, cool. Okay, maybe I'll clean up this one over here a little bit too, so that looks a little bit better. Okay, cool. So you can see that these two are clearly more steep than at y equals 1, and we really did our best to make sure that it looks like it's about a slope of 4. So we're good to go. Okay, B is pretty loaded up here. First, we know that f of 2 equals 3, which another way of saying this is that when x equals 2, y equals 3. So what we need to do is we need to actually do separation of variables to integrate this so that we can get this in the form of y equals, and then we can figure out what the plus c is by using this information. So we have to do separation of variables here. So we have to get all our y's on one side, dy over y squared equals dx over x minus 1. Okay, so now we have to integrate both sides. We have to do reverse power rule on y squared, so this is y to the negative 2. So it's going to be y to the negative 1 divided by negative 1, which is just negative 1 over y. And then that's equal to the integral of 1 over x minus 1, which is just going to be natural log absolute value x minus 1. Alrighty, so now we have to get this in y, and plus c. Okay, now we have to get this in y equals form. So what we have to do is we have to make this positive and we have to flip it. So that means that we have to multiply through by a negative, did not mean to draw that, multiply through by a negative, and then also flip both sides. So that's going to give us y equals negative 1 over natural log absolute value x minus 1 plus c. Okay, now we know that when y equals 3, x equals 2, so we say, we'll go up here, 3 equals negative 1 over the natural log of 1, because 2 minus 1, plus c. Natural log of 1 is just going to be equal to 0, because e to the 0 power is 1. So what we then get is 3 equals negative 1 over c. All right, so then if we multiply by c on both sides, we get 3c equals negative 1, and then we get c equals negative 1/3. So our particular solution is y equals negative 1 over the natural log of x plus 1, and then minus 1/3. So note the problem we just did was actually part C. This was solving for the particular solution. Part B just says let this be the particular solution, and we don't actually have to solve yet. So this was all just part C. So now I'll do part B. Okay. So part B is saying we know that when x equals 2, y equals 3, and we also know, what we're going to try to do is write the equation of the tangent line at 2, 3. So all we need is slope, because again, whenever it asks for equation of a tangent line, we're going to say y minus y1 equals m times x minus x1. Okay, we know that y1 equals 3, we know that x1 equals 2, and all we need is the slope. And the slope is determined by dy dx equals y squared over x minus 1, that is given. So when x equals 2 and y equals 3, we're going to have 3 squared over 2 minus 1, which is 9 over 1, which is 9. So now we can fill in the equation of our tangent line. Y minus 3 equals 9 times x minus 2. All right, it's now asking us to approximate 2.1, which we can approximate x values close to x equals 2 if we use the tangent line at x equals 2. So what we need to do then is just plug in 2.1. We get y minus 3 equals 9 times 2.1 minus 2. Y minus 3 equals 9 times 0.1. Y minus 3 equals 0.9. So then if we add 3 to both sides, y equals 3.9. So y is approximately equal to 3.9 when x is equal to 2.1. So again, that was part B. The problem I previously described was part C, and that's a longer problem. That's worth 5 points out of the 9 available in the FRQ. And then obviously part A was just doing the slope field.